Exercise 7A. Okay, question number 1. Okay, three forces acting on a body have moment of 7 Newton meter clockwise, 12 Newton meter anti-clockwise, and 50 Newton meter clockwise about a point X. Okay, find the sum of the moment. So you just need to add all of this moment. So if let's say your direction would be clockwise, so 7 Newton meter clockwise, and then 12 anti-clockwise, and then 15 clockwise. So you get 3 plus 7, you get 10 Newton meter clockwise. Okay, you try by yourself here. Question number 2. Okay, question number 3. Okay, find the moment or the sum of moment. If let's say you have more than one about the point A. Okay, so the force would be 5. Distance is perpendicular, so this one straight away you get 2. And if let's say you pull it up here, so the force, the rotation would be clockwise. Okay, so the answer is 10 Newton meter clockwise. Question number 5. The force is 16. The distance is 1.5. So if let's say the nut is here, if let's say we pull it here, so it will become clockwise. Okay, so 16 times with 1.5, so your answer would be 24 Newton meter clockwise. Okay, question number 8. Okay, so the force is 6 and the distance, this one is in centimeter. So you need to change centimeter to meter. So if let's say 50 centimeters, so you get 1.5 meter. Okay. And then is it clockwise or anti-clockwise? So if let's say your nut is here, you pull it down here, so it will become anti-clockwise. So 6 times 1.5 is 24 Newton meter anti-clockwise. Question number 9. Okay, question number 9, the force is 5. And how about the distance? There is no distance because it will straight away go to A. So the distance is 0. So moment is 0. There is no perpendicular distance. Okay. If let's say you have question number 10. So if let's say you have more than one force. Okay, so if let's say you have more than one force, so you need to add the moment together. Okay, so for example, so you find for the first one first. Okay, 2 Newton. So the distance, there is no perpendicular distance, so it is 0. And then plus 4. And then you have a perpendicular distance, which is 3. And then if let's say you pull it here, so the rotation would be clockwise. So your answer would be 12 Newton meter clockwise. How about question number 11? So question number 11, we have 2. And then how about the distance? So if let's say we pull it here, so the distance perpendicular, so the distance would be 1. So we have 2, 1. And if let's say we pull it like this, so the rotation at this point will go clockwise. Okay, and then we have 4, the distance. Okay, so this is the nut. So the distance, so this is 4, so the distance is perpendicular, so it would be 3. Then if let's say you bring it here, so the nut will go clockwise. So 12, 13, 14. 14 Newton meter clockwise. Okay, if let's say you have this one, question 14. Okay, question 14. Let's say you have more than one moment, then A is the nut here. So we have 12. So the distance is 12, 2. And then we pull it here. So the nut will go anti-clockwise. And then we have 6. The distance is 1. Distance is 1. So we pull it here. So it become clockwise. And then we have 6. The distance is 1 plus 1 is 2 clockwise. Okay, so we get negative 24 plus 6 plus 12. So 12 minus 6 is 0. 6. 6 minus 24, so you get negative 18. Negative 18 Newton meter clockwise. What if the question is a little bit unique? So like say we have question number 17. Okay, question number 17. If you notice that okay, the force here would be 6 and the distance should be perpendicular, but this one is not given. So in this case, this is because this is a right triangle, so you can use the theorem of Pythagoras. Okay, so if let's say this is 3 and then we have 5, so obviously this is 4. Okay, or by using the formula, you can just write 5 square minus 3 square square root. So 25 minus 9. Okay, so you get square root of 16. So square root of 16 is equal to 4. So from this point to this point is 4 meter. So the moment would be, the force is 6, the distance is 4. And then if let's say we move it here, so the nut would be anti-clockwise. So you get 24 Newton meter anti-clockwise.